Hello, my name's Sam Inglis and I'm the editor-in-chief of Sound on Sound magazine. You're watching my A to Z of audio interfaces. A is for analog. Sound is changes in air pressure, and microphones convert those changes in air pressure into changes in electrical voltage. That's called an analog signal because the changing voltage is analogous to the changing pressure. If we want to get that sound into a computer, however, we need to convert the analog signal into a big stream of numbers, or a digital signal. And that is one of the most important jobs that your audio interface does. B is for bus power. Some interfaces need a mains power supply of their own, but some of them can get enough power for their needs from the USB or thunderbolt socket. Obviously, that's more convenient if you can do it, but there's only a limited amount of power available, so usually it's only possible with small portable interfaces. C is for clocking. 200 years ago, every part of the country set its clocks locally and independently. And then the railways came along, and suddenly it was quite important that 10:30 was 10:30 everywhere, not 10:15 in Norwich and 11 o'clock in Oxford. Digital audio devices need a timing reference too, and if there's only one of them, that can be set locally. But if you want to send digital audio data between two devices, they need to share a common timing reference. That's called a clock. Often that clock can be embedded in the digital audio signal, and then you don't have to worry about it much. But in some circumstances and complex setups, you're going to need a separate clock signal. D is for many, many things, including digital, D-sub, Dante, direct monitoring, daisy chaining, disco, drainage, DC coupling. But most importantly, D is for driver. Any audio interface is only as good as the software that allows the computer to talk to it, and the key component of that software is called the driver. If you have good driver software, you'll get reliable, stable performance, you'll be able to operate at low latency without overloading your computer's CPU, and you'll get good support, which will keep your interface working for years and years to come. It's really important. E is for Ethernet. Computers have several types of expansion port, USB, Thunderbolt, PCI, and so on. What all of them have in common is they weren't specially designed for recording audio, so if we want to use them for that purpose, there are always compromises that have to be worked around. One very common compromise is that most of them only allow interfaces to be connected to one computer at once. So the big plus of Ethernet is it allows a whole mess of computers, interfaces, mixers and so on to all be connected in one big network. F is for FireWire, which used to be a great way of connecting audio interfaces to computers until Apple decided it wasn't. G is for gain. When you plug a microphone into your interface, you need to amplify the analog signal it generates to get it up to the right level to be converted to a digital signal. The amount of amplification that you apply is called the gain. Some interfaces don't offer enough gain to get quiet signals up to the right level. Some interfaces don't let you turn loud signals down enough to get them to the right level, so watch out. H is for headphone socket, which is a socket where you plug headphones in. Almost all interfaces have one, many interfaces have two, no interfaces have more than two, which is a bit of a shame. Things to watch out for: sometimes you can address the headphone sockets independently of other outputs from your DAW, but sometimes you can't. And sometimes the headphone sockets will go plenty loud enough, and sometimes they won't. I is for insert. When you're recording, sometimes you want to use a piece of studio outboard like a compressor or an EQ after the mic preamp but before the analog to digital converter. And in order to do that, you're going to need something called an insert point. All mixers have them, and a few audio interfaces have them, but not very many. J is for jitter, a new dance craze that's sweeping the nation. When we convert an analog signal to digital, we measure its amplitude many thousands of times each second, and the more precisely we can time those measurements, the more accurately we capture the signal. Any variation in the timing of those measurements creates a form of distortion called jitter, which, frankly, you probably don't need to worry about, and if it hadn't begun with J, I wouldn't have put it in. K is for knitting, which is a contrived way of talking about cable management. Not really a problem with small interfaces, but something to think about if you have a lot of things to plug in. Do you want all your sockets at the back of a rack unit, or would it be more useful to have some of them at the front? Are you okay with having mic and line level sources sharing inputs, or would you rather have separate jack and XLR sockets? If you need a lot of inputs and outputs, would it be neater to have them on D-sub connectors? Maybe you even need a patch bay. L is for latency, which ought to begin with A because it's the most important thing of all. When we record sound, it has to go into the interface, into your computer, back out again, and through the interface again. That process takes time. And if it takes too much time, we start to hear it as a delay that's called latency. There are two basic ways to deal with latency. One of them is to write really good driver software, which is difficult. The other is to create a monitoring path within the interface that doesn't go through the computer, which is a bit of a cop-out and a workaround. And it also doesn't work with soft synths. So when you've chosen your interface, do a bit of research, find out what the low latency performance is like, because it can really ruin your experience. M is for monitor control, or what used to be called the master section on a hardware mixer. If you've got an audio interface, you may well think you don't need a hardware mixer as well, because the audio interface does everything that you wanted that mixer to do. Or does it? Yes, it'll let you turn your main speakers up and down, but will it also have a button to switch to secondary speakers? Does it have talkback? Does it have mono and dim buttons? Does it have surround monitoring? Some interfaces do, many don't. N is for noise, which can be an important consideration if you're recording very quiet things. If you are, you'll need lots of gain on the preamps on your interface, and you'll need it to have a very low equivalent input noise level. O is for optical. Digital audio is a big stream of numbers, and if we want to pass that stream of numbers from one device to another, there are various ways we can do that. One very common way is to encode it as pulses of light over what's called a toslink connector. That can carry either a stereo audio signal in the SPDIF format or up to 8 channels in the ADAT light pipe format. P is for PCIe, which is another way of expanding a computer. It's great for things that need to shovel lots of data around very fast, like graphics cards or audio interfaces. So why don't all audio interfaces use it? 2 reasons. One is that not all computers have PCI slots. Tower and desktop computers generally do, laptops don't. The other is there's not very much space on a PCI card for audio connectors. So if you go down that route, you have to have a separate breakout box with your audio connectors on. That gets complicated and a bit expensive. Q is for 1/4 inch jack. Nearly all audio interfaces have some 1/4 inch jack sockets. On the input side, they're used for connecting line level sources like synthesizers and for guitars. And on the output side, they're used for headphones and very often for plugging in loudspeakers. And they're 1/4 inch wide. R is for rack mount. For a long time, professional audio equipment has come in a standard format, which is 19 inches wide and multiples of 1 3/4 inches high. A lot of audio interfaces still adhere to that format, but if you don't have other rack mount gear, you might wonder whether it's the best choice, because it means placing all the controls on a tiny rectangle at the front. A different form factor might give you more space to play with and allow those controls to be spread out a bit. S is for specifications, which is a big list of numbers that manufacturers will use to try to dazzle you into buying their products. Some of these are important. Some of them are practically the same for all audio interfaces, and there are some features that are really important that never get mentioned in the specifications. Specs you probably do need to look out for are things like dynamic range, maximum input and output levels, preamp gain range, equivalent input noise, and headphone level. T is for Thunderbolt, which was created when Apple and Intel got together and said, hey, wouldn't it be great if we had a connector that was as fast and as powerful as PCI, but didn't require you to open up the computer and insert a hulking great card? And then we could charge 50 quid for a cable. So they did that, and especially on Macs, Thunderbolt is now probably the preferred way of connecting most audio interfaces. And cables now only cost 40 quid, so that's progress. U is for Universal Serial Bus, or USB, the most widely used and the most confusing connector on the planet. It's widely used for audio interfaces because it's genuinely universal. It's almost impossible now to buy a computer that doesn't have USB ports. However, it does have a few disadvantages. One is that you generally can't connect more than one USB interface to the same computer at once. Another is that it's harder to get good low latency performance from a USB interface than it is from PCI or Thunderbolt. The cables are cheap though. V is for voltage, and specifically control voltage, which is relevant if you're one of the millions of people who's got into Eurorack as a substitute for making music. You can actually control a modular system from your audio interface if that interface is capable of creating a stable DC voltage. That means you need to look out for an audio interface that has what's called DC coupled outputs. W is for word clock. As I mentioned earlier, when two digital devices talk to each other, they need to share a common timing reference. That can be embedded in the audio, but in complicated setups where you've got lots of things talking to each other, there needs to be a single clock source that's distributed to all of them. That's called word clock, and it comes in on something called a BNC connector. X is for XLR connector, universally used for microphones, quite often used for line-level audio, sometimes used for a digital format called AES3, occasionally even used for power. The L stands for latching, which means you can't pull it out accidentally. The R stands for rubber, which makes it flexible. And the X doesn't stand for anything, but does make it very useful when you're compiling an A to Z. Y is for you and what you want. Unless you're buying something totally bargain basement, modern audio interfaces are generally pretty good. From a purely sonic point of view, they're quite unlikely to be the weakest link in your recording chain. However, if you get something that doesn't have the right features for you, or doesn't have good driver support, or just has really complicated control panel software you can't make sense of, that's a problem. So think carefully about what's actually important to you and be aware that it's often the things that aren't listed in the specs that actually make the most difference. Z is for impedance, and that's true and not at all a contrived way of getting something beginning with Z into my A to Z. Many interfaces have what's called high impedance or high Z inputs. These are designed so you can directly plug a guitar straight into your interface and have it not sound like crap. Except sometimes it still sounds like crap, because not all high impedance inputs are created equal. They need to have an impedance ideally of at least 1 million ohms, that's 1 meg ohm. So that's the A to Z of audio interfaces. I hope you found it helpful, and if you want to learn more, pick up the new issue of Sound on Sound. It's got a guide to choosing an audio interface, it's got advice on running a modular synth from your audio interface, and much, much more, including all the latest reviews, tips, techniques and features. It's out now in print, online and for free at soundonsound.com. Thanks for watching.